Most people who have an IDS, they don't necessarily deploy it correctly. And a lot of the reasons for this is, just lack of understanding, or maybe just overwhelming of too many other duties for what they have to deploy out there. So basically, by reviewing a lot of these features, which are a lot of these things that can be used to bypass both host-based and network-based IDSs, you can understand kind of where we're going and why a talk would be like this. But the point I had on the second slide was products are not perfect, people are not perfect, and that it's a process. Security is definitely a process that needs to be applied to be performing intrusion detection. So what we're going to be talking about as soon as the laptop gets up here is basically a review of some of the IDS technologies that are out there. Host-based IDS, network-based IDS, firewalls, and honeypots. Then we're actually going to talk about how you technically bypass network-based IDSs and host-based IDSs. When I originally put this talk together, we also talked about detecting and bypassing firewalls and honeypots, but the talk got to be like 2 hours, and I had death threats and things like that, so we didn't do that. But basically, we're going to draw some conclusions. Well, the first type of IDS I'd like to talk about is one I'm probably the most familiar with, which is a network-based IDS. Network-based IDS is basically look for patterns of packets, patterns in packets, and packets that should not be there. Whether you're using NFR, Real Secure, Snort, or anything like that, it's doing one of those functions. And basically, based on the packets that you see, you can sort of make assumptions about what people are doing to your network. And we got a couple of examples of that coming up here. IDSs may also understand certain types of protocols. For instance, the web protocols, the HTTP protocols. If you have an IDS that understands what's a proper URI or URL, then you might be able to look inside that protocol and find somebody doing something they shouldn't be doing. Possibly like a CGI bin attack or something like that. And then most of these network IDSs have some sort of recording and alerting mechanism. Maybe it's a GUI, maybe it's an SNMP page, maybe it's an email, or maybe it just tremendously slows down your laptop. Now, network IDSs have a lot of limitations. First of all, you have to obtain the packets. The packets are going to be hard to obtain based on your topology and based on if you have any encryption. So an encryption can come in the form of SSL, sort of at the application layer, or you might actually have a VPN in there. We'll just try to multitask for a second here. Or single task, I should say. Network IDSs also have a couple other limitations. The number of signatures that they have. A lot of people don't like to say that my signature or my IDS is better than your IDS because I have 10 times as many signatures that you do. But then again, IDSs that only have 1 or 2 signatures are not that popular. So the number of signatures is an issue to some extent depending on what you're trying to look for. In some cases, maybe not, though. I had a lot of people who said, especially if they have an FTP server, maybe they just want to look for anybody who logs into it who's not anonymous or not not the user anonymous or not the user FTP. And that could be an example of a signature, and that might cover a whole wide range of different types of attacks. And that kind of gets into the quality of the signatures. If you have thousands and thousands of signatures, but they're not very good, or they're not very relevant, sendmail whiz attacks, old Windows NT attacks, Windows 351 FTP attacks, things like that, that might add your signature count greatly higher, but it still might not be very, very useful when it actually comes to the real world. Performance. Performance is another very big issue with the network IDS. If you cannot keep up with 30 megabits of traffic, or 50 megabits a second, or 200 megabits a second, it's not going to be very useful if you have 500 megabits a second, and so on. But the biggest thing with network IDS that's a limitation is looking at network session integrity. And we'll get a couple examples of this later on. We're going to get into it in a lot more detail. But basically, if I split up an attack, a payload across multiple packets, if the network IDS does not correctly reassemble that, it'll miss it and definitely bypass it. So there's definitely a limitation. When we sell Dragon, we get into a lot of situations where people run into some attack or something on a protocol that they've never really seen before. Maybe like RIP, maybe like OSPF, things like that. And so if the administrator and the IDS itself don't really understand these protocols, that's going to be a limitation. And then finally, if you're doing some sort of packet vaulting or packet storage, trying to log as much forensics data with these network devices, you're going to run out of hard drive space. It might be easy to run over CompUSA and get another 40 gig hard drive, but if you're logging a gigabyte a second in some cases, maybe when somebody's firing up a CyberCop scan or things like that, you're going to run out of disk space. So definitely a limitation. So I just want to make one more comment here. I was momentarily frazzled with the laptop not coming up. I encourage questions. I don't really want to take any questions based on the legality of honeypots or sniffers or anything like that. So if I'm going over something and you have a question, please definitely want to stop and answer that. So what we have with this slide here is a real simple example of a basic pattern matching network IDS. Jane is at her highly advanced TRS-80 attack platform and has launched a web request, and the web request contains CGI bin PHF. Now maybe that's a valid web request, maybe it's just a post to port 80 out there that detects CGI bin PHF, but Dick over here kind of saws that pattern and says he's going to guess that Jane has done an attack. And that's what I mean when I say we look at a pattern inside a packet. Now maybe that session was maybe 2 or 3 packets that was looked at, so it might have been a couple sessions, but that's what I mean when we say we look at a pattern. Now let's say Jane downloads one of these tools, one of these thousands of script kiddie tools, Nmap, something like that, and she scans the network. Dick's over there, he sees traffic going to each of these computers. Maybe he's looking at reset packets coming from the computers, maybe he's looking at the packets heading to the computers, but in this case there's some sort of sweep, and Dick surmises with his program that there was some sort of network scanning sweep. And we're going to get into a lot more about how network IDSs reassemble sessions and actually look at these port scan attacks. Now, host-based IDS. Host-based IDS is another area of network, or another area of intrusion detection that can be used to find hackers. There's about 4 or 5 different technologies, I think I got about 4 up here, that are currently in use in combination by many commercial and free products. The most simple one is basically log analysis of the signatures. This could be as simple as going into an access log file and grepping for PHF. I've seen a lot of administrators do this, and they can find that. There's also many more advanced tools out there that actually can have databases of signatures, just like on the network IDS realm, that can look at all your various log files, whether it's an NT system, a Unix system, or an AS400. There's also this principle of file integrity checking. Tripwire is probably the best example of this tool. You take some sort of mathematical algorithm, you come up with 128-bit or some sizable number based on the contents of a file, and then you keep that in a safe place. And if a hacker or maybe an administrator comes in and upgrades a file or puts a backdoor, you're going to find out that there's a change. It doesn't necessarily tell you that there's a hacker, but it's definitely an anomaly. And there's also certain types of examples based on your operating system of enhancing kernel security. We're going to get into stack protection. There's all sorts of tools out there like SEOS that actually put access controls around certain APIs, and these can be bypassed too. I have them in here as a form of intrusion detection because, to me, if you add security to an operating system, the logs from that additional security are relevant to your intrusion detection process. And then finally, a phenomenon we've seen in the last year or 2 years is basically taking a network IDS and putting it on the host. I think CyberCop from Network Associates is probably a good example of this. So, limitations of host-based intrusion detection systems. Well, first of all, it places a load on a system. If you have a server out there and it's an Apache web server at Yahoo or something like that, that server, all of those CPU cycles in that server should be dedicated to serving up that web page. If you put an intrusion detection system on that, these cycles go to something else. It's very hard to justify to your management why you just lost 10% resources in your CPU or memory if for example, for security. It's kind of hard to measure that kind of stuff. Also, it's sorry about that. Also, another limitation is many of these systems are based on system logs. If there's a way for an attacker to come in and disable system logs, or maybe a patch from a vendor actually disables system logging, then there's no logs to consume, there's no signatures to match, and this is definitely an issue. We're going to get into a little bit more of the fundamentals of this later on. Kernel modifications and the likes to protect certain types of things can basically bypass certain things like file integrity checking, checking if network cards are in promiscuous mode, and we're getting into a lot of examples of this big in a little bit. The biggest limitation I see with host-based IDSs, and I'm not going to quote any specific vendors or anything, is simple management of it. When I was working for an ASP, we had 500, 600 servers. The idea of loading anything onto these servers, which I didn't own, was very difficult. There's a lot of management overhead with that. And then finally, the last limitation I see is basically if you have a network IDS on your host-based IDS, you're going to get into the same problems that we get into when we talk about network intrusion detection. Any questions so far? Good, just quick review. So an example of what I mean when we say we're looking at many different log files is maybe we're looking at, on a Unix system, we're looking at var log messages, transfer, secure, things like that. We're going to have a program that goes into that, finds certain things that have security relevance and make one log. And maybe that one log is going to be from all the systems on our network. So that's just one example of host-based IDS. And I like the robot. So 2 slides on firewalls and honeypots, just because I wanted to make these relevant. I think they are relevant to the intrusion detection industry. I think firewalls are probably the most overlooked intrusion detection system out there. I think this is because in most network shops, firewalls are now the domain of the network guys. It's not the security guys anymore. Firewalls are part of the infrastructure, and they probably don't get reviewed in the security process. But I think that it's definitely a good source of intrusion detection logs. Some of them even have denial of service features. They'll detect denial of service and port scan. Now, honeypots is also another area that's getting some press lately. Again, CyberCop Sting is out there. There's the defense toolkit, I think, from Mr. Cohen. I forget the actual name, DTK I think it's called. But basically the principle on a honeypot is to simulate some sort of system. And maybe this system is a sacrificial system, just a couple of Linux boxes you bought from CompUSA and stick in your DMZ you really don't care about. Or maybe it's something a little bit more advanced like a big Dell with multiple CPUs running 10 or 11 VMware clients. Or maybe it's even a commercial product. But the point of the honeypot is to simulate some sort of network, some sort of hosts where traffic to that host that would attract traffic to that host of people that are probably suspicious. The one example I was associated with when I was in the DoD, there was a large telnet application. People all over the world, all over the US military, telnetting in 20,000, 30,000 sessions at the same time, many, many different servers. Well, it's kind of hard to tell who's good and who's bad. Putting up a few extra servers in that case and seeing who is connecting to them, that was very useful in this case. So honeypots can be kind of useful. That's sort of it for what I want to talk about as far as just a review of all the IDSs. Some people might point out that there's other types of intrusion detection system, right? Marcus Radium's given a couple talks about putting tripwires, putting Trojan horses on your network, things like that. There's also physical security and things like that. But that's just a quick review of some of the IDSs that we're gonna talk about. What we're going to focus mostly on here is research that's been done over the past 2 to 3 years by folks you've heard about. I'm definitely going to reference all these places and add a little bit of new stuff. But there's so many new people getting into network intrusion detection. Some of them have never heard about Secure Networks Incorporated, some of the work that's been done to do bypassing network-based IDSs. So what I've done is try to pull a lot of this together and talk about it. So the first thing we're going to hit is basically network intrusion detection. This is the slide that we're going to come back to probably a couple different times. Basically, all network intrusion detection systems that do some sort of reassembly or reconstruction of traffic have 2 really big system resources that they use to keep track of things. The first one is an IP defragmentation queue. Now what I mean by this is basically there's a hunk of memory set aside, maybe it's a hash table, maybe it's just memory that's mallocked, maybe it's anything like that, but the purpose of this memory is to sort of take these various IP fragments as they come in, arrange them in memory, and then under some set of circumstances magically say, here's the new packet, and then evaluate that packet with according to the signatures and the network IDS's rules. Same thing for the sessions. If you have a telnet session or a UDP session like DNS that's over multiple packets, those bytes out of each of those packets are going to get picked up and put into a queue. So what I'm saying here is the network IDS might look and see these blocks of yellow. I know this is kind of Sesame Street-ish, but it's kind of hard to maybe describe some of this in one PowerPoint slide. Basically, the network IDS's job is to pick up all these pieces and put them back together correctly. The problem is there's many, many ways to fake out how a network IDS is doing this reconstruction. If one can insert or cause a valid piece of packet or data to get dropped or added to this queue, it invalidates the entire queue. The other thought is, if this process is CPU computationally extensive, then maybe doing lots of this stuff can cause the IDS to get very, very busy. So both of these principles we're going to kind of talk about a little bit. Any questions so far on this? I haven't mentioned anything like queuing or sequence numbers or anything like that yet. Sir? Oh, no, question? No? I was deceived. So the first example of network intrusion detection bypass we're going to talk about is fragmentation. Basically, if you have a network IDS that does not reconstruct fragments, simply fragmenting your attack using a couple different tools will allow you to bypass that session. There will never be a hunk of data that can be used to compare your signatures or your port scan theories or port scan algorithms or anything like that. It's a drain on resources. We kind of talked about that a little bit already. And then fragmentation also has this interesting property of what happens if I send you two pieces of data that overlap in the same data. Like, let's say I want to send you 8 bytes in a packet, or maybe 16 bytes. And if I fragment that into 2 bytes of 8 bytes in one and 8 bytes in the second packet, and maybe I send you a third packet that's a copy of one of those two, what do you do with that third packet? What if it overwrites? It turns out that many different operating systems handle this differently. And this is definitely an issue. If you know how an operating system handles this, you can cause it to reconstruct your session differently than how your network IDS does it. So a couple examples of attacks here. Like I said, if you don't have an IDS that does fragmentation or defragmentation, you simply fragment your traffic. You don't have to do any overwriting, don't have to do anything like that. Let's say you have an IDS that does do fragmentation resetting. If you can find an anomaly where the network IDS is reconstructing the data differently than the target host is, then you can actually use this to your advantage by sending in data that will get incorrectly reassembled. And third, in a perfect world where all these network IDSs reassemble traffic exactly the way they should, you can still do sort of a resource attack where you start the beginning of some sort of attack. Maybe you send the first or second half of the fragment, then you send in lots of other attacks. Maybe they don't even have to be attacks, they can be valid traffic. And then once you've exhausted that queue, which is sort of a guessing game, but a million attacks should probably do it, finish that first attack, and the system theoretically would not pick it up due to resource management. What we're saying is because there's a limited amount of resources, limited memory, things like that, sessions that's starting to be looked at might get sort of set aside when there's resource management at the network IDS. Any questions on this? I'm going to give out lots of references for this.
What do you think that the user resource IDS also set up on?
The question was, won't something that uses up the resources of an IDS set off an alarm? Depends on the IDS. I mean, I can think of one that when you use up all the resources, it doesn't work anymore. It's not ours, but when you peg the CPU to 100%, it literally dies. It doesn't see any traffic or things like that. There's a lot of very robust systems out there that once you start pegging the CPU 100%, things like that, they can sort of queue things, priority, maybe stop doing certain things that are CPU intensive. I don't want to give out too many examples of stuff like that, but it depends on how the network IDS is designed. Any other questions? So TCP, basically reconstructing a TCP session is very difficult. There's a lot of different ways to insert additional packets in here to confuse how the network IDS basically reconstructs the traffic. For those of you who haven't read Comer or Stevens or anything like that, basically there's volumes and volumes written on how TCP sessions should be reconstructed. There's things like sequence numbers, acknowledgement numbers. There's flags in your packets that say, hi, I'm talking to you, I'm done talking, and things like that. It turns out that many vendors implement these things sort of 95%, 99% accurately than as these RFCs are out there. These one or two things that they do differently can be used to sort of desynchronize a network IDS. One example of that I don't have here is simply spoofing a reset packet or a SYN packet. Let's say there's some network IDSs where in order to get a session started, maybe it has to see a synact packet, or maybe it believes that once a reset packet shows up, it's time to process this session queue. If you can spoof a reset packet in there, the network IDS might say, hey, it's time to do this queue, or do this laptop. Is there a question? Somebody trying to bypass my laptop? I think the LCD projectors are pulling faster than my laptop can push that. No. That's too bad, 'cause I got some nice graphics coming up. It's not bad. I had this full motion AVI, why the Concorde crashed, but I guess we're not going to see it. But that's okay. I'll do a reboot here. Get to watch Ron flail about with the laptop again. But basically, how many of you have or don't have the slides? Okay, yeah, I know, that's good, that's good. So the two examples I had in the slide about doing desynchronization attacks against TCP basically come into an advertisement for why not to buy compact laptops. The first example that I'd like to talk about is simply doing a real simple thing, which is basically TCP checksums. Every TCP packet has a 2-byte field, 2-byte field that is a checksum on the validity of the data that it has inside it. Every operating system will sort of take in that a packet as it sees it and verify that the checksum works. So a real basic attack is to start talking to a server and then have the network IDS do a reassemble on that and actually send in an extra packet with maybe a slightly different payload or a slightly different sequence number where the checksum is indeed invalid. And what happens is the network IDS picks up that packet and inserts it into its queue, thereby invalidating that queue, basically adding extra data into it and causing a signature to not match. The host on the other end, I get a lot of people ask questions, but what does the host do? Well, the host ignores it. The host basically throws it away. There's all sorts of stuff in the kernel that does validation and checking of these packets as they come in, and the host simply throws it away. So that's a real simple example of how to get some data into a session. There's a couple of actually there's many more other types of attacks, but the most other common attack that people do is they start playing with TCP synchronization numbers. When two systems start talking to each other with TCP, there is something that I would consider kind of elaborate, but basically there's sequence numbers that basically talk about the data that's been transmitted from the client to server. They basically follow how much data has been set. Well, there's a couple different examples where I can start maybe stepping up these sequence numbers, maybe adding thousands and thousands of bytes that never really got transmitted, maybe sending invalid sequence numbers. If the network IDS does not know how to follow these sequence numbers, then it'll get confused. And a lot of it can also happen with acknowledgement numbers if you sort of switch around the client-server model. So I was really hoping that the laptop would boot up quicker because the next slide's pretty good. The slide with the skull on it, where we start talking about time to live, is another example of more at the IP layer of how to get a packet into a system. Let's say you have a network IDS system that's out in front of your network, and your network is some sort of tiered architecture such that the network IDS is maybe 2 to 3 hops in front of your target servers. With a time to live value in an IP packet, it may be possible to get the network IDS to pick up a packet and put it into its queue when the packet might never actually get to where it's going. And I know I could explain this a lot better if I had the slide up. But the point is, let's say you have a network IDS that's in front of maybe 2 or 3 routers, or more typically at an ASP where you have your external Cisco 7500s, maybe your switches, maybe you're even doing routing on your switches, maybe you have some routing loaded up. That's at least 2 hops if your network IDS is in front of your routers. If someone starts sending you packets with time to lives of, I swear it was working before. At least all the porno hasn't come up yet.
Is that what IDS is called?
Yeah, it's from McAfee though, so. Comment? When the slide comes up, everybody clap. Thank you very much. Thank you. Thank you. Is this worth a second round of applause for that one? Okay, no. All right. Okay, I like the X. All right. So basically, maybe you have a set of routers. We have a lot of customers where they have at least 5 or 6 different hops into their network. I mean, I know that seems kind of a lot, but that's a lot of different types of routes that an attacker can take into your network. These are typically your educational universities, your government agencies, your pseudo-government agencies, where they have lots of routes and topologies and backdoors and things like that. So this can be a problem with your network IDS. As I said, if you send a packet in that has a time to live of like 1 or 2, after 1 or 2 hops, it's gone. It never actually makes it to the server. If the network IDS picks that up, that's a type of insertion that you can do to defeat the IDS. Now, another one that can, at least this slide will be up, but I can talk about it if the laptop dies again. Another one that a lot of network IDSs I know about don't do is this principle of the maximum transfer unit. Let's say you have a VPN or a dial-up modem or something like that, where the maximum transfer unit is specified around 600 bytes. What's the maximum transfer unit? Basically, it's a setting you have to put into your Windows to get your modem to work. Now, basically, it's the maximum size of a packet that can be carried by a transfer medium. So typically, like for Ethernet, the maximum transfer unit is about 1,500 bytes. If you have a VPN, they kind of chop off about 10 or 20 bytes for some VPN headers and things like that. If you're doing something like dial-up modems, ISDN, things like that, ATM, they can get, these maximum transfer units can be bigger and smaller. If you have a medium where the maximum transfer unit is a certain value, and on one side the maximum transfer unit is bigger, there's an opportunity to send in a packet that's not going to get to the target server. So the example we have here is maybe there's a VPN between our 2 sort of things that look like routers there. And if we send in a packet which is bigger than that medium, the first device is actually going to take that packet and split it into 2 fragments. It'll fragment it. This is what's supposed to happen. If you have cable modems, you might see that after these packets have been fragmented, that they have a bit set that says don't fragment. So if you have a cable modem or something like that, or I haven't checked most of the DSL networks, all the packets that you're getting are marked with don't fragment. They don't want to refragment these things anymore. The backbone of the at-home cable network is mostly ATM. They have ATM clouds, and once the packets seem to come out of them, they're marked with don't fragment for some reason. I'm not exactly sure why. I'm not a WAN engineer. But in this case with network IDS, it presents another opportunity to insert a packet into the network IDS. Let's say we send a packet into this channel, but we mark the packet that's too big for this channel with that bit that says don't fragment. What happens at that border router? It drops it. And it may even actually send an ICMP fragmentation needed event, which you can kind of see if you're doing some sniffing there. But if the network IDS does not understand the maximum transfer unit, and to know that a packet that's bigger than this, that has a don't fragment bit, go into this set of IP addresses, is never going to get there, it's another opportunity for insertion. So any questions about that? Sir?
If it doesn't get to the web server, it still gets to the NID system, right?
Right. The comment was if it doesn't get to the web server, it still gets into the NID system. And that's the point. If we have a session going to the web server where we've maybe established a connection to its port 80 and we're talking to it, and we're going to do an attack, the idea is in the middle of that attack, we're going to send in one of these packets, and we're going to insert a character or a letter into that attack session, where at the network IDS, it's going to look at that session and it won't match any known signature. Sir? Sir?
Would you have problems with sequencing numbers? Because that is satisfactory.
The question is, wouldn't we have problems with sequencing numbers? Maybe on the TCP side, but the time to live values in the IP header So it's really just a matter of how the network IDS is redoing things like fragmentation and TCP checksums, things like that. Theoretically, the way this would work, and I'm going to give you a URL of something that does do this. You would establish a session, maybe it would take a kernel mod, and then right in the middle of a session, a second packet's going to get sent out with an improper size with the don't fragment bit set. Question? I can't hear you. Absolutely. The comment was, could you do something like have an RDS attack where you're going to establish a connection to the web server, you establish it, send SYNAC, and you're talking to it, and then you send in a reset packet that says, I'm done with that session, but the reset packet never actually makes it to the server, but the IDS sees it. That would absolutely work if the IDS believed the reset packet. I know of a couple IDSs out there that don't believe reset packets going into a protected network, which would defeat this. But it's definitely a possible attack. Any other thoughts? Sir?
Well, reset packets actually do not have data in them against the RFC specification, so an MTU attack would not work.
Actually, that's a very good point. What I've found is you might find a way to send a reset packet with like a 2,000 byte or like a 1,000 byte payload or something like that. It might be against spec, but it still could work. I mean, you definitely could make the packet. It might not be RFC compliant, but you definitely could make a packet that has that in it.
Well, only if the OS had a TCP/IP stack that follow RFC specifications and RFC processes.
Right. But this packet would never even make it to the OS. It's for the network IDS. So the network IDS would have to know that packet. Any other thoughts? Sure.
Overriding fragments and reset things just smell bad. Like, did it just flag it as, well, here's something going on?
That's what we do at Dragon. Yeah. And the other thing that we're going to be doing with Dragon, instead of just reassembling all the stuff, is when we smell something bad, just shoot the session down. Overriding fragments don't normally happen. TCP desynchronations don't normally happen. But it turns out that there's a lot of devices out there that will find these things for you. There's a lot of switches out there, like from F5 and Cabletron and things like that, that actually understand flows and things like that. And when they see these desynchronized attacks, bad overriding, they just drop the session. And it's, I'm not saying it's not going to be an issue. This is a very important issue. What I'm saying is there are some tools out there that can help with this.
What was the comment? What did you say?
Oh, the comment was, aren't like I don't think he said like, but aren't fragments that overlap bad and TCP sequence numbers that get desynchronized bad? And I kind of agreed with him. So, sir, ma'am.
So your IDS, is it configured to know the network configuration in order to handle these?
The question was about the IDS we sell. I'll be happy to talk to you offline. I don't want to talk about it here. What I will say is most of our customers run multiple IDSs and they have a very good understanding of their network. So it's definitely pretty good. And there's more systems coming out that, like the Hiverwold guys here, they scan the network and the IDS kind of correlates with that. I think the Intrusion Com guys are working on something like that. I know we're doing something like that. I think Cisco's doing something like that. So yeah, it's going to be coming out. Any other thoughts or questions? Sir?
In a case like this, where you're setting this packet which is too large for the internal network, too large enough for the external network, this packet has to have a sequence, correct?
If, well, there's some sequences and things like TCP, sequence numbers. I mean, some of the higher level applications might have sequence numbers in them, but it depends on the protocol that you're talking about. So, other thoughts or questions? One day, I got a call from Rainforest Puppy, and he said, "Can Dragon handle this?" And Jeff, are you here? No, I don't want to point him out. Where's he at? Okay, he's hiding up there. Anyway, he calls up and I think it was an email or something like that, and basically said that we had a lot of problem with our signatures and stuff like that. And specifically, he started talking about these ways to go into the HTTP protocol and screw with it such that the network IDS didn't match a pattern. Let's go back to Jane here. Jane, oh, come on. There we go. It could be. In this example, I said Jane is looking for CGI bin PHF. Basically what a network IDS might do would be look throughout all the port 80 traffic it sees for that one pattern, and whenever it saw it, it might say, hey, here, I have a PHF attack. And maybe it's even sophisticated enough to understand what a URI is and a URL and things like that. But it turns out that lots of web servers will accept a lot of different variations on these things. The examples we have here insert things like slashes, backward slashes, do reverse traversal directory where you actually specify a directory that doesn't even exist and then you dot out of it. What this meant was that lots of network IDSs had to sort of emulate or run basically a little web server. Lots of assumptions, lots of performance hits, lots of different ways to possibly get something into a network IDS. These examples that are here are in a tool called Whisker. I got a URL for it later on. But basically what this means is you can do some sort of web scanning and not necessarily be picked up by a network IDS. Any thoughts or questions on this? Now the other thing that's going on here is there's certain other types of applications. For instance, the Telnet protocol. If the network IDS does not understand the underlying protocol, there's certain things in there that can be almost used to bypass an IDS. For instance, the backspace key. We have a lot of people out there who want to be clever and things like that, and they connect into a Telnet server, and maybe they know that there's a network IDS. I can think of a few military intrusion detection systems that are out there that emphasize analysis of the Telnet protocol. Excessive backspacing can cause a problem. Let's say somebody types SU root. Well, that might be a 7-character match, SU space root, which would be kind of interesting. However, SU X backspace root is a completely different string. If the network IDS does not understand that there's a backspace involved there, it's not going to match it. It's definitely not going to match it. And there's application gateways that are out there that will do this kind of thing for you, and it's definitely a way to do it. Mr. Song.
It's actually more than just having your network IDS understand the protocol. With regards to reinforced LP stuff, basically what you're doing is looking at sort of these weird one-off encodings or arbitrary mutilations of the URL that certain web servers can accept. And obfuscation is one thing. An IDS can handle it if it knows how to decode it correctly, and the end user will accept it. But there's another problem in ambiguity, where you have bifurcated analysis of something that may go either one of two or many ways, and there's not really a good way to deal with that. If, for instance, in your example, in your Telnet protocol example, you have SUX backspace root. What if you had SUX backspace delete, et cetera, without understanding what the actual negotiated term cap settings are, for the connection? You won't know whether a backspace will be a backspace, delete delete, et cetera. And so there's sort of a harder problem of you have a whole decision tree based on the input that you're getting, and it's not just that you have to understand how to code something in one way, but you have to understand and there's not enough information on the wire to know whether or not the end user is going to accept this, path A or path B or path C. So what do you do about that?
Absolutely. No. For the folks on this side of the room, basically, I think what he said was, in a nice way, was this is too simple of an example. That there's lots of other things you can do, not necessarily even just with Telnet, but given any application, there's probably just one or two more levels you could go to. Whatever level the NIDS goes to, you can probably go one step further and confuse the NIDS. And I want to capture some of the stuff he said. Things like this backspace. Well, what about backspace delete? What about backspace, delete, delete, backspace? You know, it's all how it's implemented to get it redone. Was that okay?
Well, basically, I mean, I guess the analogy is, you know, if someone's talking and you're eavesdropping on them, they're speaking French. If you understand French, you can decode what they're saying, you know. But what they're speaking, a mix of French, Esperanto, Klingon, you know, any number of things all mixed up, and you're not familiar with any of them. You also don't know whether or not the person on the other end of the line understands French, Klingon, Esperanto, so you don't know what's actually being transmitted. Without sort of a priori knowledge of what, you know, the receiver understands, how do you know which path to take? How do you know what the codes is valid and put it not?
Absolutely. Again, very good comments. It basically what Doug's saying is that we really need to know without knowing what the client and server are actually talking about and what the information really means, almost at like a Cliff Stoll type of level of, you know, what's being said here, what do they understand? A lot of this stuff is assumption. A lot of people don't realize that a lot of these network-based IDSs, basically, it's assumptions. There's a lot of you know, things that you have to decide when you're writing a signature, when you're looking at the traffic, when you're analyzing the traffic. It doesn't necessarily mean that, and this can turn around and bite you sometimes. It's cool. Is your application gateway program done yet? He's smiling for the folks over there. Doug posted to the intrusion detection mailing list a while ago with something sort of like NID or frag router, but it's sort of like application router that did some of these things that we're talking about automatically. But I don't know if when you're finished with that, let me know. Sure.
Back on the HTTP. If you look instead of going and saying, you know, these X, Y, Z is bad, you have like each knowledge about what you actually have on your web server, especially if you're not writing any CGI scripts. But you when setting up a set of script signatures, that these are the valid.
The comment question was, if you know, like you have a web server that doesn't have CGI bin on it, could you simply just write some signatures that look for people going for CGI bin, like in any URL? Was that right?
Or basically just say these are the requests that are valid.
Yes. Absolutely. If you know what's valid. I won't name the company, but we actually had one of our customers, their e-commerce site had their name in the URL. And all they wanted to do was write a signature that for any web request that didn't have the name of the URL, flag it as suspicious and log it over here. And you can do that with NFR, you can do it with drag, you can do it with you do it with a couple different things. So.
Is doing something along those lines hinder an IDS in terms of performance?
The question is, would that hinder the performance? Well, you know, if you're going to do that instead of 300, you know, PHF or CGI bin rules, sure, you're just going to enhance performance. But it's probably just one more signature. Any other thoughts or questions?
Yeah, right here. Can you go to
Yes, I can.
Basically, there's an infinite amount of varieties used to get into that, or variations. Why can't you just set, instead of going against the infinity, go against the finite set of no commands and set up your IDS so that it only allows what was in it?
The comment was, why not just go, instead of with this infinite number of combinations of trying to tweak with the protocol in order to bypass, just go with what's known. The problem is, let's say the command ls, that's a known command, that's probably legal. I might be able to make it delete, letter, or letter, delete, s. So it's still a problem. Your primitives can be split up.
What I'm saying is you only allow ls.
That's like host-based security. Another comment, sir.
On a different level, though, what are you saying? I mean, the real solution to all these problems with ambiguity and everything is really to sort of proxy, sanitize the data before you get it. There's been some work done by Vertex and some other folks who have looked at this. The way you do it is you have like a bump in the wire, which just cleanses the TCP stream, TCP scrubbing they call it, such that the data coming out on the other side is going to be exactly as you want it, and I can expect it to be.
Right. Doug's comment was that there's being some work done. Vern Paxton, I believe, I'm not familiar with this work. I'll have a URL for some of his work later on. where they basically pre-process or post-process the traffic, so what you get is nice, well-behaved traffic. Another corollary to that is, at the host, a lot of things like PHF attacks and telling, you might be able to get a log out of a host, so it's the same information, but instead of pulling it off the wire, it's coming out of the host. My one comment on this telnet type of stuff is, because we could talk for a while about many different examples of how to bypass somebody using telnet. If somebody's breaking in and doing something, I mean, what's to prevent them from just running SSH on a high port or something like that, which you may be able to detect with a network IDS, or running some sort of proxy that does ROT13 or something like that on the traffic, which would be very easy to defeat a network IDS looking at that kind of stuff. Doug, come on up, pull up a share. No, come on.
Actually, Fairfax has an interesting set of heuristics for that as well. Just published a paper on detecting stepping stones, which helps to correlate, if you have like connection A, connection B, B to C, C to D, and you only have C to D and A to B, you can actually correlate those two connections being related by way of timing and looking at latency, packet sizes, to detect traffic that way. So he's been able to detect just that example as SSH on a high port.
I don't have references for that. Go to Yahoo. There's some work out there detecting backdoors and things like that. Vern Paxson, Yahoo's Vern, and look for stepping stones. It's a paper on detecting backdoors, which I meant to put that in here, but I didn't get a chance. Some of the URLs in here for this NIDS work: Whisker from Rainforest Puppy, Frag Router from somebody who, that guy over there. Horizon, are you here? Frac a couple of whiles ago. Basically, this was a loadable module for Linux that implemented some of these techniques we're talking about. This loadable kernel module did this kind of stuff. Probably the best paper out there is Insertion, Evasion, and Denial of Service Attacks. This is the one that happened about 2-3 years ago from the folks at Secure Networks. Mr. Patachek, I apologize if I got the name mispronounced, and Tim Newsom. Basically, they did a lot of research on these various attacks that can be used, and they go into a lot of the theoretical attacks that are still present out there. That URL is valid for that, by the way. If you go to the Network Associates homepage and try to find this paper, you kind of get like a Network Associates advertisement, so it's a little bit different. And then Bro is something that I actually had about 3 or 4 slides on this Bro tool that it sort of says, I'm only going to look at responses from my servers. I really don't care what the attack was or what you may have done to fake it out or desequence it or things like that. But if I see the etc password file fly out of my web server, that's a problem. So doing that kind of stuff. And Bro kind of embodied this. Let's look at stuff leaving our network. That was at least one thing I got out of it that I thought was good. Sir?
How do you spell Vern's last name?
Ooh, tell me if I'm wrong. P-A-X-O-N? P-A-X-S-O-N. P-A-X-S-O-N. He wrote like TCP/IP or something like that, right? Right? Yeah. Okay, bypassing host-based IDS. Basically, most of these slides that we're going to talk about here are really get roots and things like that, but they have lots of applicability, a lot of backdoors. They have lots of applicability for if somebody's running tripwire or some sort of host-based signature analysis, that it has relevance to what we're talking about. So Greg Hoagland a while ago he wrote for FRAC. Basically, it was a real Windows NT rootkit, was I believe the article. Greg, are you here? Okay. With a 4-byte patch to the kernel, you basically disabled all access. Now, the reason why this is relevant is if you have full access to an NT server and somebody's running maybe Accent's tools or ISS's tools or Black Ice or things like that, you can turn them off. And this is very important. I mean, if you have that kind of access to defeat these kind of things, you can turn them off. We're going to talk about detecting these things later on. Now, maybe you don't want to turn them off. Maybe you want to go to their logs and manipulate their logs or things like that. So it's very relevant. In the Unix space, people are much more, I found that people are much more familiar with backdoors on the Unix side. It's pretty easy to bust root, put a backdoor, put it on a high shell port, things like that. What was interesting though is a while back there was a program called ITFS .c, which is like a Linux 2.0-ish, to one of the earliest 2.0 kernels. Basically a loadable kernel module that basically did anything you could ever want to do to bypass an operating system. I've seen similar tools for Solaris, for AIX, for HPUX, for different things like that. This ITFS ITFS tool, which I believe was only like a couple thousand lines, basically made it so that the module was not in proc modules, right? That's one thing I've seen a lot of people do is write a module, and you might not be writing files or anything like that, but if the sysadmin can go to /proc/modules and find this program called ihackedu. Whatever, I mean that's sort of an issue. So it's not in proc modules. It can hide files. It was hiding processes. It was hiding network connections. It was doing all this without trojaning programs like netstat, like ls, and things like that. So this is much more of a subtle backdoor. And if you're running tools like Tripwire or anything, you might not, there's nothing there that's been modified. You've modified the kernel. So nothing got matched. And there was a couple other things that tool did. Another thing that really isn't host-based intrusion detection system, well, I guess it really is, was StackGuard. And basically StackGuard was a program, I have a URL for it later on, that helped to defeat buffer overflows. Now I'm not going to do the buffer overflow, what is a buffer overflow? I'm not going to do that talk justice. Greg Holan did a good job yesterday with that. But basically we're talking about overwriting data on stacks, changing the way subroutines return into data that we just sent them. And there's a lot of work out there on this. I have URLs for it later on. The basic thing that StackGuard was doing was sort of saying, aha, when I go into this subroutine, I'm going to put this extra hunk of data when I make the call. If that hunk of data ever changes, they call this a canary, there's a good chance that there was a buffer overflow, some sort of overrun, or things like that. So what happened was, I think a couple months ago, or maybe it was late last year, I'm not sure, but some very smart folks figured out a way to defeat this. Basically, they said in some cases you can basically overwrite the return pointer and not do a no-op sled or not do this huge amount of data, and basically keeping this canary intact. So what the fix was there was to XOR the canary with the return pointer, so that that it had to be overwritten in case it was missing. Now the point of all this, though, is that all of these programs that are out there, StackGuard, SEOS, any of these access control list-based API programs, it's an arms race. Unless you have secure boot on your system, at some point you will run a program, or an attacker may be able to get your system to run a program that's hostile to you. So if you have a host-based intrusion detection system, the host-based system is going to be running on a non-trusted operating system. So that's sort of some high-level theory there. One of the more common ways to bypass host-based IDSs that are doing file integrity checking is through some sort of library redirection. There's a lot of patches of the kernel out there where you can redirect the the execute command, the execute API. If you can do that, basically you can simply say, hey, if somebody's executing a program, like login or something, run this program first. Run my program over here in /temp. We don't have to go and Trojan login. If you go and Trojan login, the next time somebody comes along with an MD5 tool, they're going to get a different answer for the login program, and they may find that suspicious. But by redirecting these APIs, you can simply redirect them to run different programs for you. So again, another example of bypass. How many people here have actually run Tripwire on their systems? Okay, or similar type stuff. That's good. How many false positives with that kind of stuff? Anybody? Lots, right? And how many of them are hackers? Probably not that many. It's another type of integrity checking. I have one other slide here on the host-based stuff. The same conversation we had about the protocols with HTTP, they're applicable. If you have a signature-based log analyzer for your web server, for your Apache Access log file, and somebody comes along with Whisker with those extra slashes in there and things like that, you're going to bypass that as well. Same thing with the FTP port commands and things like that. If you're looking for a well-behaved port command and somebody comes in with something that's a little bit different, some way to encapsulate or enhance the data in some effect, you're not going to see it. Definitely not going to see it. Got a couple FRAC references here. A lot of really good information. I basically, when I was doing this, preparing for this talk, I said I'm going to go back and read all those articles I was supposed to read when FRAC came out, never got to. So I kind of went back and reread them and pulled on that for this talk. I actually found the StackGuard site, the documentation, they're very, very good. All right, a couple other different types of practical bypass techniques for the network IDS side. We're going to get into some port scan detection, port sweep detection, things like that. But very simply, I've run across a lot of sort of practical things people have done that are not necessarily the best thing to do with a network-based IDS. First of all, is it in DNS? When we do Dragon, we send we do our keying based on the host name. We always get either Dragon or IDS1, IDS2, IDS3, and you can pretty much take company name, do a DNS lookup on IDS1, IDS2, IDS3, .companyname.com, and you can probably find it in DNS. So that tells you a couple different things there, but it's sort of that balance of management versus security there. Does it shoot down connections? There's a lot of network IDSs out there that shoot down connections. Well, there's a certain debate over whether or not that's a good thing or not, but it's definitely a way that you can find out that you're being blocked. Certain tools out there, I think of BearNet, when it shot you down, it actually, if it was like a web shot down, it actually gave you a nice web page that said, hey, the BearNet session wall has shot you down, and so that's definitely a way to be able to identify that kind of stuff. One of the things we have in Dragon is the ability to send out, when we shoot stuff down, we shoot it down in a certain way, and again, that could be used to identify that somebody's running Dragon. Every system out there has got something like that, and so that's definitely a non-passive technique. Again, when I worked for the ASP, a lot of our folks in marketing and stuff, they wanted to take our intrusion detection boxes and paint them, fluorescent red or something like that, and say, here's the IDS. It makes great stuff for the tours, but it might not necessarily be the same thing if you have an adversary who's taking a tour. So I mean, that's definitely something you want to look about. I've seen examples of all these things, so it's definitely a problem. And finally, can the alert messages be seen? There's certain famous websites out there, maybe like the Anti-Online site. When you go to their IDS, you can actually see the messages. It's pretty obvious that they're using a certain commercial vendor out there. So if you can find out that kind of stuff beforehand, maybe they accidentally have a web-based management of their IDS and you stumble across that, you may be able to determine what kind of IDS it is. If you're scanning, NetRanger, ISS, most of these products out there actually have open ports on the management side. Almost all the network IDSs out there can go stealth mode, but on the other NIC that actually connects to their console or their server, whatever it is, there's probably some open ports on there that you may be able to identify what's going on. A corollary to this is the whole, I think Mudge has talked next on finding the network IDSs that are basically anybody who's sniffing. The same principle goes there. I mean, you can definitely find things that way. Does the web page say, we're protected by XYZ IDS? I mean, that's a dead giveaway. They might be protected by it, but are they administering it? So it's definitely a thought. So once you identify a network IDS, how do you avoid it? Well, basically, are there other routes into the network? We have some customers that have so many routes into their network, they're only looking at outbound traffic. They've basically given up on the idea of putting in NIDs at all these places, large government organizations, large places like that. So if you know that, can you possibly, hack, find a route, bounce off somebody's home computer, things like that. There's many different ways to sort of route around an IDS that they may be able to do. Modem dial-ins, things like that. IDS cost money. They might have enough money to put in the DMZ, but not in the modem dial-up rack. Those kind of examples, things like that. If you know the IDS, have you read an article or a post to the IDS mailing list or that said, oh, it did not detect this type of attacks? For instance, not many IDSs detect route-based attacks, routing attacks, OSPF, BGP, things like that. Well, if that's an attack path for you, then the IDS might not detect that. And then is there a technical bypass technique that we talked about? Can we just simply do fragmentation of these TCP desynchronizations, things like that? Can we overwhelm it? And overwhelming it might be simply sending lots of attacks in, or taking a tool that replays network sessions and just injecting that into the local layer. I found that if you have layer 2 access, you can overwhelm almost any network IDS out there. You can spoof Ethernet packets, you can saturate that line, you can do things like that. From far away, IP at least 1 or 2 hops away where you can't inject anything into the medium, you have to do things like send packets that cost a lot of the CPU to process. Now maybe this is defragmentation of just normal traffic, maybe it's a TCP desynchronization of normal traffic, but the bottom line is if you concatenate these things, let's send in a fragmented packet, well the fragments need to be reassembled, let's send some bad reset checksums in there so that some packets are dropped there, and then actually let's reassemble that session. I mean, that's a very long path through a CPU, a lot of instruction cycles there. And then on the topic of port scanning, there's many different ways to go to a network IDS and just simply slow roll. Basically change the way you do network scanning in order to look at how these network IDSs reassemble the traffic. Sir?
What you didn't talk about, like, when you transfer an IDS, like a firewall shows up on port 208, you have a rule on it using Cisco border data, like border router, to just have a rule that denies that identifying frequency.
The comment was possibly using routers or ACLs, firewalls to deny these open ports and things like that. Absolutely. Getting back to the very first slide, security is a process. If you know you're running an IDS, it's got some open management ports, things like that, you may want to put a VPN between that and the console. You may want to put a firewall in front of that and block external traffic, or you may even want to run a firewall on the IDS. We have a lot of people who use IP filter, very good firewall, on the various programs that they use, and you can do all that kind of filtering right there. With the topic of port scans, basically all network IDSs are not created equal when it comes to detecting port scans. And there's many things that people can do trivially to sort of defeat port scan detection. What's a port scan? That's basically a topic. Connect into from one IP address to another, look for many different open ports. Port sweep is let's talk to all these different computers on a network on the same port, maybe look for open sendmail servers, open web servers, and things like that. Typically what I've seen is you have obvious scans, sequential, from 1 to 1024, things like that. Maybe they're going to randomize that a little bit. Maybe they're going to do a sweep. Maybe they're going to do something stealthy, spread it out over time. Basically, if you take one IP address and for a given amount of time, log all the connections it makes onto a network, such as the lower graph is maybe all the the last octet of your Class C solder block, so maybe .1's on the left, .2, .3, .255 over here, and then on the left maybe graph all the open ports, all the ports that you see traffic for. So if everybody was coming to a web server on one system, you might just see one dot in the middle. Maybe our IP address was like .50 on port 80 or something like that. But if somebody comes in with a port scan, if they randomized it, if they've gone vertical or horizontal, it's still going to be a certain number of ports that were hit on a certain IP address. Basically, most network IDSs look at this data and say, oh, is there a threshold here? Maybe there was a port scan. And then the same thing, sort of switching the arguments, switching the port and IP pairs, you can look for sweeps. And basically it's the same type of thing. Are there more packets going into these IDSs, or going into these IP addresses that are horizontal? What happens though when somebody comes in and slow rolls that? I mean, retaining all that traffic data in memory is very consuming. And I mean, if you can slow roll an attack or slow roll a scan so it takes an hour or a week, the longest scan I've seen is a 3-day scan that was actually observed. Again, trying to go below the threshold of things. But let's say we're not going to do a time-based threshold. Let's simply just come in and we're trying to do TCP pinging to see if hosts are alive. Well, maybe I'm going to go from host A to B to C on my network, but I'm going to change the destination port every time. Port 2000, port 9000, port 1, port 60,000. That can constitute a sweep and basically see if their systems are alive or not. Same thing goes, I've seen simple modifications to program like Nmaps out there. Well, they'll just simply increment the destination port every time. You get sort of a vertical sweep like that. I've seen a lot of military sites scan with techniques like this. The point of all this is that it's hard to keep this stuff in memory. There's a limited amount of resources, and you sort of have to keep a bit bucket of all the packets you've seen, and then sort of evaluate that with what kind of port scans that you've seen. What we're starting to see is the technology from these distributed denial of service attack, the Trino, the TFN, things like that, where the agents themselves are used to scan. So let's say you want to scan 5 ports on a particular system. Well, if I do that for my system, those 5 ports in a short amount of time might actually set off a threshold. But if I can send those 5 packets in from 5 different systems, for testing purposes, for instance, then basically, you know, the network IDS, they're not going to correlate anything. It's going to be very hard to do that. There's some tools out there. There's probably there's an IDS out there called CyberTrace that does this very well. It takes statistical anomalies and it does the many-to-many scan. So it's definitely a different area of research that we're going to be seeing. Just a couple more slides here. Host-based IDS, typically, the only time you're really going to identify one of those is once you're on the box. Maybe that's too late by that time, but if you're on the box, you might be able to identify it in the logs, you know, grep, var log messages, tripwire, you know, that kind of thing. And if you actually get into that, then you have the area of what are you going to do? Are you going to go into cron, disable it? Are you going to go into the registry and try to disable it? Are you going to go into the logs and maybe delete the logs of your actual intrusion? We've actually seen a couple cases where people have gone into the logs and not deleted them, but modified them. There's tools out there where you can just, you know, basically run some Perl programs. If you see your IP address show up there, you can change it to be something else. So the integrity of these things can be definitely attacked. I got 2 more slides, but I can just talk to them real quick. There's been some threads on the IDS mailing list lately and on Security Focus about social engineering to bypass IDSs. Probably one of the more original things I've seen is people posting fake, you know, hack me at this IP address. Hey, I'm doing a test. Why don't you come here and hack me? And then when you do a DNS lookup on that IP address, it's IBM.com or you know, something like that. So there's definitely ways to social engineer and get that kind of stuff in there. But the generic way, what I lose sleep over is when I have a lot of agents out there. I have you know, host-based agents, network agents, and it's all coming back to some central source. Maybe it's a commercial vendor, like we have the Dragon server, for instance. Maybe it's an application service provider where they've invested in a large Oracle database, you know, and they're pulling in their logs and things like that. What I lose sleep over is somebody finding that and then doing a denial of service on that or doing some sort of attack on that corrupts that service. So there's definitely things out there that in order to bypass these things. There's definitely techniques that you can do given any set of products you have out there in order to bypass them. So sorry for running through the end of that, and my apologies for the compact laptop. I'll take questions if you'd like, and thank you very much.